Alright, today's lesson was basically day 2 of scatterplots, and the content objective was I will use direction, form, and strength to describe a scatterplot. Now we didn't actually go over the definition of what a scatterplot is, but basically a scatterplot, it shows the relationship between two quantitative variables measured on the same individuals. So basically these two things measure two different things, but they measure them on two things that are very much hopefully related. Sometimes they are related, sometimes they aren't. What a scatterplot attempts to do is to either prove or disprove it. Now, based off of the information we're going to be covering today, we're either going to be proving that these two, quantities happen to be, have a strong relationship or lack of relationship. Now, kind of some stuff that's standard. One of them is going to appear on the horizontal axis, so that's, x-axis. And then basically the other values are going to appear on the vertical axis or the y-axis. And then basically the data is set so that, you have x and y, so those are going to be fixed points on the graph. Now, things to remember from previous lesson, we talked about explanatory variable being x. So that's going to go on the horizontal axis if possible, the x-axis. Now, we usually, like I said, we usually call the explanatory variable x, and we call the response variable y. So when we actually graph these, we want to make sure that we're consistent with those definitions. Now, sometimes you're not going to have explanatory or response variables. It's not going to be clear like, hey, this causes that or this may cause that. Again, we're trying to prove that with scatterplots. So if there is no clear distinction between which is which, then basically you guys have the option of picking which one goes where. Now, when we describe scatterplots, these are the four things I want you guys to focus on. 3 of them were part of the objective. This one was not there. But they're all going to be very important, so we're going to just cover what some of them, or what all of them mean. Now, a quick reminder, you guys don't have to copy everything that I have on my slides down. You don't have to. It's like your notes and your neighbor's notes might not be the same. You guys might, interpret things a little differently, so you might need to work a little harder or not work as hard, depending on who you are. I'm hoping you guys know who you are at this point, in your, let's say, educational career. Now, I will say this though. Some of the examples that I'm covering in are not in the book. So these are examples that I had to go, scour the internet to look for. I had to find something that I can break this down a little further than just doing 1 or 2 examples in class with you guys. So the first thing I want to talk about is form. So the way that the scatter plot appears, whether it's on paper or on an actual, a graphing calculator, is very important. Now, if things are kind of just all over the place like this, and it doesn't, there's no clear form, it's not a line, it's not, a different shape, then there's no association. So basically there's no form. Now, sometimes it might take on a form, and it's not a line, so we can say no linear, no association, or you could also say it's a curved association because basically that's what it is. Now, if it does start forming like a line, then we can say it's linear. Now, there's a line drawn through here. Clearly, it doesn't go through all the information, but you can also clearly see that the information is going down at a somewhat linear, pattern. And then you have some where basically they are literally a straight line. You graph them and they form a straight line. Those are perfect linear associations. So those are just some of the forms that you might encounter. Now, this one is direction. This one's kind of basic, something you should already know. If you're very, you guys are usually at this stage in your mathematical, career, you have learned about slope already. So right here we have positive and negative associations. So basically we have a positive slope, we have a negative slope, and again it has to do with typically linear associations. So if you have, for example, on the previous one we had this one right here, there could be an argument made that this is, positive, this is negative. So you really wouldn't slap either of those labels on there because it has both. Now, strength. This is a tough one. If you take a look at the scatter plots that we have in front of us, so look at this one and this one. This says 0 correlation, so near 0 correlation, and this one says weak correlation. And if you look at them, they're almost identical. They're almost identical. So this one, you can clearly see that things are all over the place. There's no like clear shape. There's no like, you know, it's not really forming any lines or anything. So you can make an argument here that it's positive or negative because, you know, again, it's all over the place. Again, this one looks very similar to this one, but we can say that this has a weak correlation because, well, these are closer together. Like if I drew a line through here, it looks somewhat linear, and it looks like everything is kind of grouping towards that line. Now, you guys might notice some numbers here that are maybe hard to read on the screen, but basically these are something called a coefficient correlation, where we're going to learn about in the next section. And that, if you have this number, using that number you can say this with more certainty or one of the other four options. But I'm not going to get into that right now because today we're just basically doing it by hand, and we're going to eyeball it, essentially. Now here again, there can be, you know, points of argument here. This one looks very similar to the previous one over here. This one has a weak correlation. This one supposedly has a positive, you know, moderate positive correlation. Well, you can see that things are grouped a little closer together, and you know it is fairly linear and it's going up, so positive correlation. And then this one looks very similar to this one as well, but again, things are grouped closer together. And again, these numbers right here are important for that as well, but it's something that's going to be talked about in the next section. And then, you know, if you have positive, we have to have negative too. Now again, these two, very similar in nature. This one is closer together. Whenever you have, you know, points that are scattered but close in proximity, they're going to have a much stronger correlation. Alright, now outliers. Outliers need to be mentioned specifically. So, for example, if I were to go back over here, and right here it says, so like, if there's an outlier on your scatter plot, you have to mention it by name. You don't just say, there's an outlier. You say, so for example, if I go over here, it could be argued this is an outlier right here. And you would basically look on the graph to about where it is. So this one's about, let's say, 0.5 and like 90. You would literally say there's an outlier at, you know, 5 and 90. You would specifically name the outlier. You don't just say there's an outlier and it's over here in this direction. You specifically name what the coordinate is. Now right here it's not very clear what you know it could be. So when I say 5 and 90, I'm, you know, estimating. But on actual problems, we'll have the data sets. You can name it specifically. Now, here's our first example, and I have to read this part here first. I swear this is in the book. I'm not looking for problems that involve animal cruelty. It just so happens that, you know, that's the problems that I've been finding. There's a lot of weird stuff in our book. But this one basically is about the endangered manatee. So manatees are large, gentle sea creatures that live along the Florida coast. Many manatees are killed or injured by powerboats. Here are data on powerboat registrations in thousands, and the number of manatees killed by boats in Florida in the years 1977 to 1990. Now, this is, like I said, it's in the book, so as we go through this, if you want to have your book along with the video, so you can look at the numbers and do the math, perfectly okay. But there's two parts, or actually several parts to this question. The first thing is, A, we want to examine the relationship between the number of powerboats and the number of manatees killed by boats. So which is the explanatory variable? So again, you're looking for one of these two things to explain the other. So number of powerboats to the number of manatees killed by boats. So, and this one I feel like it's fairly clear which one explains the other, especially when you say killed by boats. That's kind of saying that this is going to be caused by this. So for this problem, whoops, this didn't have it in here. Sorry. For this problem, the powerboats are the explanatory variable. That's going to be our value for x. And then we're going to say that the number of manatees killed by boats is our y value. Now, I don't want to explicitly say it's the response variable because we can't say that yet. So this, powerboats, that is going to be our explanatory variable, but we're attempting to explain, to prove that this right here, the manatees killed by boats, is the response. We can't say it yet because we haven't looked at the numbers yet. We can't just assume that. So then part B says, make a scatter plot of these data. So be sure to label the axis with the variable names. So you don't want to just say X and Y. You want to say power boat registration or number of power boat registrations, and you want to say number of manatees killed. You don't want to just say X and Y. And then after we've done that, we have to answer the question, what does the scatter plot show about the relationship between these variables? Now we're going to answer this using the 4 things we discussed earlier. So we had form, strength, direction, and outliers. I don't believe I covered it in that order, but if I did, that's random luck. So for this, you will need graph paper. And then one of the things that we're still, talking about is scale. What's an appropriate scale? Now, I did this by hand a couple times, and, well, the scale didn't really matter. I was able to get the same results from all of them. Just by looking at the graph, I could tell you the same things about direction, form, strength, all of that. It didn't matter what scale I used. I still got the same answer. Now, here is the data. Now, here's the data that I got from the book. Now, you notice we have the year. This is powerboat registrations. And this is basically manatees killed. Now, sometimes you're going to get charts where there's extra information. So the extra information here happens to be year. We don't necessarily care about that. What we do care about is these two. We want to know how many powerboats are registered and basically how many manatees were killed. And I will remind you guys that these are in the thousands. So this is actually 447,000. And this large number is 719,000. Now, again, you want to label this appropriately. So I have right here, my x-axis is powerboat registration in thousands. And my y-axis is going to be manatees killed. Now, like I told you guys before, I picked several different scales. For this purpose, I chose this one right here. Is 440, and I basically went up by 40 each time. And then on this one, I decided to go up by 10s. I find though, if you pick smaller numbers for both of these, you get a better picture, but it also makes this ridiculously huge. Right here, I have a range of 180. That's a pretty large number, so it'd mean more of this, and it'd be basically your graph is more spread out. And again, your scale, it really won't hide anything from you. Unless you pick something like super ridiculous, like you make this like 0 to 400 and you made these really small. But you want to be consistent with your scale. Now, here's my version. And I know the dots are kind of small. But using this right here, I can then say a few things about this, relationship. So again, the second part of B was, what does the scatter plot show about the relationship between the variables? And my answer is here. The scatter plot shows a strong positive linear relationship with no outliers. Now, I got this down to one sentence, and I was able to talk about these 4 things: form, direction, strength, and outliers. And you don't have to write a sentence for each one, or even a paragraph for the whole thing. In one sentence, I was easily able to define all of it. I have strength, I have association, I have form, and I talk about outliers. And that was it for this lesson. Tomorrow we're going to discuss what this means. What does having a strong positive linear relationship with no outliers mean? Does that mean there is a response variable here, and that happens to be the manatees killed, or does it disprove that? And then today I only have one problem for you guys, because I feel like drawing one of these scatter plots takes quite some time. So here's the problem, and it's on page 125. It's 3.7. You're basically doing the same thing we did, as part of this lesson. And in class, took about 25 minutes to get to the problem, and this video took roughly almost 15 minutes. So hopefully it doesn't take you that long on the actual assignment. But email me if you guys have any questions.